Welcome back to Tech Tip Thursday i3 edition. So previously we talked about all of the components to the top and anything related to the microwave assist side. But today we're going to talk about the other side of the oven, the part that makes it hot, and blows air, the convection side, the oven side of the oven. So on this oven we have two 12-amp fuses, so that's 208 volts there, and those are going to be controlling your stir, your power supply, which is in turn going to control your control board, and then also those two 12s control your blower controller, which is in the back, and then also this solid state relay. This solid state relay controls the heating elements on this side of the oven, and then that blower motor controller controls the two blower motors down on that side. Today we're going to talk about the solid state and the heating side. So the way this works is the board is going to call for heat. It's going to say, I'm not hot enough. It's going to tell our solid state relay to turn on. So these are our control signals right here. And it's going to basically imagine it's a light switch. Board says this isn't hot enough. It tells this to turn on, which is then going to give us our voltage from these two wires, so our browns, over to our whites. Now those are going to travel down and go to this side. And the first thing it's going to go through a high limit thermostat. High limit thermostat is if the oven gets to 572 degrees, we want this to turn off. We don't want it to exceed 500 degrees. That's bad. So if you find one of these tripped, you need to start asking yourself, what has caused it to go to 572 degrees and trip? And if you're on the back, your tripping is going to be this red button. So if he clicks, first thing you should be asking is, why were we chasing so high and exceeding our temps? And the store will usually say it's 600 degrees and it shut off. At that point, there's two things it could be. Is we could be going over temp because the board is calling for heat nonstop, or the solid state is stuck. How can I test that? Well, first thing we can start with is putting this guy to amps, and we would clamp each one of these and watch what our current is on each one of these. That solid state should be cycling. So if you have one side of the solid state that's cycling on, off, on, off, on, off, and one side that's sticking on, then we know it's our solid state. The other way you can test it is if you're wondering if it's the control board or the solid state stuck. Well, the solid state's gonna sit and be a solid state. We can take this guy and unplug it, and if we continue heating, then we know our board is not the issue. Now it's the other side. What if it's low? Which is a good question. Low temps can be related to your solid state as well. So we can see we're calling, and we come down here and we're not getting current draw on one of these two wires. There's two possibilities. Solid state could be bad. That's an easy swap. Could also be our high limit thermostat. One of these sides can go bad, and the way to test that would be you treat this similarly to a light switch. You should have very little resistance across these taps. So if I take this guy off and this guy off, I should be able to monitor, or I guess test across that. I believe it's those two. Yep. I think it is directional that way. Anyway, let me grab a multimeter quick. Running out of hands quickly. All right, so we would take our multimeter and we can test here and here, and we should get very little ohms. If this is really high, we'll find ourselves, first of all, our high limit thermostat is going to be pretty hot. And then the other side is we're actually creating a series circuit where this has become a load and it's separating up that voltage to that heating element. So that can cause a problem. But in this case, it's extremely low. You'll see a much higher resistance on that if that's the problem. And it'll be like partially tripped. And then there's the other side of it, which is, what about the heating elements? And the heating elements are a good question. So the way I kind of handle heating elements is I highly doubt both heating elements are going to be failed. So what I'll do is I'll take my multimeter, and we'll see if I can do this one-handed. Now, for those who service HHB ovens versus i3 ovens, you have two heating elements in here, just like in HHB, but these are actually paired. So this top one and this one are together. So like these two are one heating element and these two are one heating element. And you can leave them wired and we'll get a reading of About 14, somewhere in that range, 14.6. So if we sneak down here, we should get roughly the same reading. And there you go. What you would find is you'd go in here, and one of these will say OL. If you get OL, that's an open line, which means that it ain't working. So then you'd be swapping one of these heating elements. So that would be if you had low temp. Hopefully that helps you out. Next week we'll probably talk about blower circuit. That's pretty fun. And then we'll see where we go from there. Thanks for watching. Hope this series is helping you out a little bit. I know there's a lot to these ovens, and maybe you already know all this, but for those who don't, it's definitely nice to get a little refresher and learn those things. So thanks for watching. We'll see you next time.